All right, let's do some math for our class. What are we doing? We're in math 335. And we're doing some review of functions and specifically linear functions. And these were 2.3 and 2.4 in our 35 class. So, let's just look at a function and decide whether or not it makes it. Let's look at a graph and decide whether or not it makes a function. So I've got x like that. I got my y-axis like this. I'm going to do a green line. I'm going to do a red line. I don't know if these colors show up on Zoom, so we'll find out. Ooh. Now let's do a blue line. How can we tell what makes a function a function when we're looking at the graph?
Like this straight.
It's called, yeah, it's called the vertical line test. So let's do a vertical line test for each graph. If I follow along the green line, it can only cross my line once, the vertical line. And for the vertical line test, the green line passes. So this will be a function. If I do the red line, it also passes. If I do the blue line, it does not pass. It hits the entire blue line all at the same time. So the blue line is a fail, no function. Another one that would fail would be something like that. A parabola that opens sideways. It would not pass the vertical line test either. I got a lot going on there. Maybe I should have given graphs so I could do more topics at once. I guess I'm gonna have to redraw the graph anyways. Let's say we've got some weird graph like that. Increasing sections where the graph increases. As you go from left to right, it goes up. So following the green line, this is increasing along this section to right about there. It stops being increasing. And then here again, it starts being increasing again. Decreasing as it goes to the right, it goes down. So that would happen right here. And that's it. So that's my decreasing section. These two red sections are my increasing sections. And where functions are constant regions, as we go to the right, there is no change in height. And that would be from here onward. This section is constant. Give me a second with that. Get my gel out. The wind's starting to fuck up my hair.
Yeah.
All right, let's look at some other ideas. We talked about domain and range. Oh, it's the room. Fuck me up.
Yeah, I thought it was the weather, I was like.
Ideally, this was supposed to be a constant function right here. And let's say it meets right there. So for this graph, the domain, recall, is all possible x values that work on, that are accessible on a picture. It looks like it's starting all the way from -infinity. And it keeps going over here, and the arrow is at an angle, which implies it keeps going, so it's going to go all the way up to positive infinity. So as we do the domain, we look from left to right to see where the graph is. When we do the range, we do the y, and we start at the bottom and we go up. So this thing keeps going down, and so apparently it's going, it starts at -infinity, and as we go up, the graph stops going up here. That's at 1, 2, 3, 4. So it's going to go up to 4, and it is hitting the 4, it's not below the 4. So we're going to use a bracket on that. A hyperbola. We'll be doing these later this semester. Let's look at the domain for this graph. In fact, go ahead and take a shot at it, and then we'll do it together in a second. Don't want to take all the fun from you.
I have a question.
Yeah.
You showed us multiple lines where where like goes up and down like that and then has a constant region. Are we ever going to get an example of a function that graphs like that?
I can come up with a function that has that, yeah.
Okay.
In fact, we'll do it right here. That's an example. It has to be a piece that are called piecewise functions. And as we go further in the chapter, I'm sure they show up. Since you're asking now, we addressed it. What's the domain for this hyperbola? Anybody? Negative infinity to infinity, yeah. The arrows heads indicate that it keeps going. And since they're at an angle, yeah, it's going all the way to the left, it's going all the way to the right. What about the range? It's not the same.
Or it ends off at like 4, or no. Wait, no.
Remember the range, if we're doing it, we're following the y value. So let's follow the y value. It starts at negative infinity. And it gets to -2. And it stops at -2. So I'll put a bracket there. It does not hit the blue line in between -2 and 2. But when it gets to 2, it starts back up again. So we'll do in union with 2 to infinity. I was sneaky.
But it's like 2 lines.
That depends entirely on how they're doing it. The reason why we need something here is because there's a gap where there is nothing going. Like I could easily do a graph without like writing a value for it. I could have this is doing that. And then when we get to here, it does that. And so like maybe it's not there, but it's doing this. It does have a solid point there and it's going this way. As I go from left to right, it is starting at negative infinity and going to positive infinity. And then I go from up to down, it does the same thing. And there's still a gap. So this would be negative infinity to infinity for both. This is another piecewise function. This one has the gap because there's nothing in this region right here. In terms of the y. We will see that more later. Quite a bit later. I don't think we did with conic sections for a while. But I thought I'd make it fun for you. Let's see, what else did we talk about? Do you guys want practice with evaluating functions, like plugging in a number and seeing what the value is?
Sure.
Okay. Actually, let's see. If I change it up something to make it fun. Let's say f of x equals x squared plus 3x plus 2. And let's find out what f of 1 is. And then let's take a look at f of, let's see, n minus 4. That was my boy before his haircut yesterday. He's so fucking cute. He's not so cute now.
Did they went short?
And we just asked for it cut short and it's short.
Did they take all of it off?
It's not all off, but compared to this, yeah.
Have the mustache now and do all like everywhere else. with the mustache?
It's not bald, but it's short enough that it's not cute like this anymore. I didn't take a picture. I need to take a picture and
Don't embarrass him, Motley.
he doesn't give a shit. He doesn't. What changed though was as soon as he got done with the groomers, he got back inside. And all of a sudden the motherfucker had more spring in his step and he could fucking get higher with a vertical leap.
It's like, oh, Paul is weight on me now.
Right, or I like his, in a couple seconds, his spur was a little bit matted and it was hard to get because he just attacks any brush you use on him. But they got rid of all that, so either it's the extra, I don't know, 8 ounces of fur that's gone or. Yeah, it's something. But he used to be able to leap in my wife's lap and not mine, and then all of a sudden he just. My chair's just a little bit higher. All of a sudden, just fucking scampered up.
Dynamic.
And apparently, today, before I left for work, he figured out how to get under the bed. Which he has not been able to do yet. He cuddles with us for a while and then he wants down and before we go to sleep. Now but. If we're on the bed and like the other person's sleeping and you go like, and the other person puts him on there, he'll just fucking pounce on him. To wake you up and say hi, you know, he's playful. Now he can do it on his own. That's not gonna be good,
Like, oh, no.
right? All right, so what we're doing, everywhere we see X, we're replacing with a 1. I'm gonna use parentheses because it's a good way to go. I've got 1 squared, which is 1, plus 3 times 1, which is 3, plus 2. So f of 1, add those up, equals 6. We do the same thing for f of n minus 4. Everywhere I see an x, I'm going to replace it with n minus 4 in parentheses. This takes a little more work, but when we do it, see what we get. I get n squared minus 8n plus 16 plus 3n minus 12 plus 2. And if I gather like terms, I've got just the single n squared. I've got negative 8n and 3n is negative 5n. And I have 16 minus 12 is 4 plus 2 is 6. So that would be f of n minus 4. And up here we add f of 1 equals 6. We could. We didn't factor this one up here though, and we could have defactored there. If it's the problem wants you to factor or take it further. Like if you, and there will be a common point where we do, like we're looking for where it equals 0, and so we'll factor into stuff like that. But as of now, we're just gonna leave it there. The idea is getting you used to replacing one letter for something else. All right, let's say we have. 4x minus 5y equals 8. And we want to write this in function form. This means we have to isolate y. And then replace y with f of x. or g of x, or it's just some function of x. We get to pick whatever letter we want. So, if I want to get y by itself, that's what isolate means, get it by itself. I'm gonna move the 4x first, do subtraction. I get negative 5y equals negative 4x plus 8. And then I'll divide everything by negative 5. And I get y equals, on the x, the two negatives cancel out. And I get 4/5 x, and then I don't need a plus there because I got just a single minus. Minus 8/5. Finally, we're just going to replace y with f of x. Oh my God, my hair. Fuck. I also want to see if that fucking hand sanitizer works as fucking gel.
Don't do that.
Probably bleach my hair, right?
What if the two all of them? Guys, don't try it.
It's all fucking I can feel it, it's froing. It just started throwing up. All right. It's like staticky, it's fucking getting worse.
So that's the art department.
I'm not putting fucking glue in my hair. That sounds like a terrible idea. I don't know, does it glue, Elmer's glue wash out?
Yeah, that is still refitting.
Do I look like I've ever been a punk?
There,
I didn't watch them fucking do their hair.
we have no Elmer's glue or like egg whites.
Huh. Why glue though? Why not just get gel and do it? I guess the glue might make it stick better than the gel. I'm looking this shit up now. I don't know if I.
Really, do I trust you?
Because there have been, I've done a fucking mohawk phase, like during the pandemic.
Yeah.
During the pandemic, when I'm like, I don't have to leave the house. I just fucking I did it to myself. And it wasn't long, and, you know, it was like, it got up to here, but wow.
No, dude, one of my friends, she moved to prom, like her mohawk, yeah, sorry, no. Even out, but
Okay. Now it's at least not hitting my forehead. There we go. Yeah, I didn't try, it was hard to do with gel. I didn't try glue.
that must be what, yeah, no, we got to do worse.
I wanted to dye it blue too, but I didn't, I just didn't go that far.
It's too far.
My rebel phase during the pandemic was only so far. So when we have an equation in the form, like we started off with 4x minus 5y equals 8, and we ended up with f of x, which was y, equals 4/5 x minus 8/5. This is called the standard form. And we just give a letter for all the constants and we make it capital. X plus by equals c. And this is in linear function form. It's also in slope intercept form. If I leave the y in there. We're gonna cover that today. I believe it's gotta be today. It's gotta be today. There's no way we just did linear functions, we're not doing it. Where the idea is the value in front of x is m, and this is our slope. We talked about this boy being rise over run. It's also a change in y, y2 minus y1 over x2 minus x1. They do like to write delta y over delta x. Because delta, the delta symbol means change in. So that's where we get the part with the slope name. The slope is here. And if we plug in 0, we let x equal 0, f of 0 just ends up being this value right here, the -8/5. When x equals 0, this is the y-intercept. So this gives us the y-intercept is at 0, comma, -8/5. And plugging in 0 is really easy. I don't have to do anything but just read the last number. There's no math involved. So I don't want to do it with that one because -8/5 is going to be a bitch to use. So it's 4/5 isn't so bad, but -8/5 is. Let's choose a different function to indicate how we can use that for graphing them. X and it's y. We will take a look at let's do y equals 3/4 x minus 1. So what we do is we're going to use that idea of the slope and the intercept. The intercept is when x equals 0. When I have 0, the value of y is -1 here. Which means we have a point at 0, -1, which is right there. And then the slope is m equals 3/4, which is my rise or change in y over my run, which is change in x. Which means I can go up 3 and right 4 and put a point. Alternatively, if I introduce 2 negative signs, I could write this as -3 over -4. And it shows me going the other direction. I go down 3 now and left 4. And then I connect the dots. Is ready for some more? A lot of times in reality, we don't get the equations right away. When you go deep enough into mathematics, you will learn how to find the equations for any line, given the points that you have. Generally, when we know it's a straight line, we just have two random points. Let's say we have the point 3, 4, and we have the point -5, 2. We can find the slope and plot this line by doing that y2 minus y1 over x2 minus x1. And it doesn't matter which one we label 1 or 2. I'm going to do it both ways. I'll call that first set 1 and the second set 2. Remember, these are x and y. So my y2 is 2. And my y1 is 4. My x2 is -5. And my x1 is 3. Maybe I'll use black for the fraction and the minus signs to make it a little bit clearer. If it helps you, you can put it in parentheses and it doesn't change anything, but it might make it so you don't fuck up the minuses. If I work this out, I've got 2 minus 4 on top is -2. -5 minus 3 on bottom is -8. And if I simplify this, I get 1/4. Why don't you guys try the other way? Make the first point over here, let's call that point number 2, and call that point number 1. And do the slope, find the slope for it. All right, so my y2 is 4. My y1 is 2. My x2 is 3. My x1 is -5. When I do this, I get 4 minus 2 on top is 2. 3 minus -5 is 3 plus 5, which is 8. And that will also reduce to 1/4. And why don't we try checking out what happens when we use this slope from either point. So I need 3, 4 to fit on the graph. I guess I didn't need to make the bottom part. Three, 4 is right here. And -5, 2 is right there. If I start from here and I use the 1/4, I go up 1 and over 4. And I can go up 1 and over 4 and hit that again. So it took me 2 steps, and that's because I divided by 2. I can also do the -1/4. -1/4, sorry. And go down 1 and left 4 steps, even though I didn't put the points on there. If I start out over here, I kind of need to do the -1, -4 the whole way. Starting here, I go down 1 and then left 4. 1, 2, 3, 4, and I hit there again. Down 1, left 4, 1, 2, 3, 4. So it does, I still hit all the same points. It doesn't matter which point I start with. I'm still going to get the same line. And it didn't matter which one I made, point 2 and point 1, I still get the same slope. So you have a lot of leeway in what you want to choose. None of those were the y-intercept. This problem didn't start with a y-intercept, and to be honest, the y-intercept looked like it might be a little crappy. As I can see from where it crosses, it's not at an integer, so it's going to be a fraction of some sort. Looks like it might be 3 and maybe 1/4. That's just looking at the picture, maybe. We'll explore how to take this and end up with the slope-intercept form. I believe that's on today's docket. So the slope-intercept form, again, is we have the slope we call m, and we say plus b. So that's my slope. And my intercept comes from my y-intercept comes from that, which means it's 0, b is the y-intercept. Let's see, what else do we got? I think that's kind of good. You guys want another one to do? Let's do, give you another one. Does anyone need it? You guys need that up longer, Christopher, Erica?
No, I'm good.
I'm good too.
Okay. Let's do, I don't know what M is. Let's start with the point, -2, -3. And we're gonna go over to 4, 1. So figure out the slope and then draw the picture. You are free to pick whichever path you want. All right. Let's see what you should have got. I will call this 0.2 and I will call this 0.1. Yeah, -3 over -2, those are my x's and y's for the point number 2, and then we got 1 on top and 4 on bottom here. So my slope is -3 minus 1 is -4. Bottom I get -2 minus 4 is -6. So this should reduce to 2/3. Much easier with graph paper. -2, -3 is here. And 4, 1 is right here. Presumably, if we use that slope, we can get between them just fine. Sometimes you only have the slope in one point, but it still does the same thing. We do rise over run, so rise over run. I'm gonna go up 2 and run 3. Up 2 and run 3. And that will be my line. Any questions? All right, let me stop on the record.